Hello, welcome to Anybody Can Learn. Today we will do practice for our quiz 1. Consider a cube of edge length 4, center at the origin with its corners represented as combination of the plus or minus 2. So this is the coordinate of our data point. These 8 points make up a data set D. Based on the above data, answer the given sub-questions. Find the covariance matrix C of the dataset. Enter the sum of all the entries of C as the answer. We calculate the covariance matrix by the formula C is equal to 1 upon n into bracket x minus mu transpose multiplied by x minus mu, where n is the number of the data point and mu is the mean. So these are our 8 points and this is how our cube look like. These are all the possible sign combination of our data point. Now calculate the mean. The mean of the vector is calculated by the formula mu is equal to 1 upon n multiplied by summation of xi. We have 8 points total and they are the equal numbers of plus 2 and minus 2 in every coordinate. The average of every coordinate is exactly 0. Therefore, the mean vector is 0. What is covariance? Covariance tells us whether the two variables increases together or not. It tells about the relationship between the two variables. Suppose maths mark increases and the physics marks also increases, then the covariance is positive. If maths mark increases but physics marks decreases, then covariance is negative. And suppose if there is no relationship, then the covariance is 0. In our example, the mu, that is mean, is 0. Therefore, our covariance formula become C is equal to 1 upon 8 multiplied by summation of xi multiplied by xi transpose. Suppose our x is column vector ABC, then its x transpose become row vector ABC. So multiplied xi into x transpose will give us a into a square, a into b, ab, a into c, ac. Second row become b into a, ba, b into b, b square, b into c, bc. And third row become c into a, ca, c into b, cb, c into c, c square. So this is how our x into xi transpose look like. Now calculate it for first point. Take the point 2, 2, 2. So our x is column vector 2, 2, 2 and row vector, then it x transpose become row vector with entries plus 2 and plus 2. Now calculate it x transpose. So x transpose is our matrix with all entries 4. So first row become 2 into 2, 4, 2 into 2, 4, 2 into 2, 4. Similarly second row is 2 into 2, 4, 2 into 2, 4, 2 into 2, 4. And third row become 2 into 2, 4, 2 into 2, 4, 2 into 2, 4. So all the entries are 4. Now instead of computing all the 8 matrices one by one, notice a pattern. Every coordinate is either a plus 2 or minus 2. and the diagonal square, and the diagonal entries are the square values. So it can be either plus 2 square or minus 2 square. So plus 2 square will give 4 and minus 2 square will give 4. Therefore, every point contributes 4 at each diagonal entry. We have such 8 points. Therefore, we have such 8 matrices. Therefore, the diagonal sum is calculated as 32. Look at here. This is a one matrix for 1 point. Similarly, we have 8 points. Therefore, we have 8 matrices similar to these. At each matrices, we have 4 at this position. So, for at each 8 point, we have 8 into 4, 32 entries. At this position, 32 entry. At this position, 32 entry, and this position 32 as an entry. For values such as xy or yx, some point will have xy as a 4 and other will have xy as minus 4. Now add them all together. At 8 points, we will get 0 as our entry. So exactly the same cancellation occurs for xy and yz. This happens because the cube is perfectly symmetric. Therefore, every off diagonal entries is 0. So our final matrix, summation of xi into xi transpose matrix, will look like this: 32 0 30 0 0 32 0 0 0 32. Now remember our main formula. Main formula of covariance matrix is 1 upon 8 into summation of xi into xi transpose. So divide this matrix by 8. So 8 divided by 32 will give 4. So our covariance matrix is 4 0 0 0 4 0 0 0 4. Now sum all the entries. So 4 plus 4 plus 4 will give 12. So our final answer is 12. Next question. Let V is element of R3. Be the sum unit vector. Find the variance of the data set along the direction of V. So now understand what is variance. A variance tells us how spread out the data is. Suppose 5 students score 50, 50, 50, 50, 50. Every student got exactly the same marks. Therefore, the data has no spread. Therefore, variance is 0. Now suppose another example. Consider the marks 10, 40, 60, 80 and 20, 110. The marks are spread out, so variance must be large. Remember that variance measures the spread of the data. What does along a direction means? This is one of the most important idea in the PCA. Imagine looking at a cube. If you stand in front of the cube, you see one view. If you stand on the side, you see the another view. If you the cube does not change, only your viewing direction changes. PCA asks, how much spread do I see if I look along a particular direction? What is a direction vector? A direction vector represented A direction is represented by a vector. Example, V is a transpose vector 1 1 0 0, means look along the x-axis. Looks along the x-axis. Example, V 1/3 multiplied by transpose vector of 1 1 1, means look diagonally through the cube. Now solve our question. The variance along a V is calculated by the formula V is equal to V transpose CV, where C is a covariance matrix. Now consider a V as a column vector ABC, then its V transpose become row vector ABC. So V transpose into V is A into A plus B into B plus C into C. So V transpose V is A square plus B square plus C square. Since V is a unit vector as it is given in our question, its length is 1 because A square plus B square plus C square is 1. Now consider the formula of the variance. Variance is a V transpose into C into V. Now substitute the value of the C. In our previous question, we calculate the covariance matrix as a 4 0 0 0 4 0 0 0 4. So substitute it in our variance formula. So this is how our variance formula will look like. Now recognize that if we took the 4 outside, then it become 4, C is equal to 4 into I. I is our identity vector because its diagonal entries are 1 and all other entries are 0. So our C will look like a 4 into matrix 1 0 0 0 1 0 0 0 1. So variance, substitute these in our variance formula. So V transpose into bracket 4I into V. Now take 4 these outside. So 4 multiplied by V transpose into I into V. The important property of identity matrix is I into V is V. So 4 into V transpose V is, since V is our unit vector, V transpose V is 1. Therefore 4 into 1 is 4. So our variance is 4. Next question. Standard PCA is performed on a center data set in R3. The first three principal components are W1 is equal to 1 upon square root of 2 multiplied by 1 minus 1 0. W2 is 1 divided by square root of 2 into bracket 1 1 1, and W3 is 0 0 1. The first two principal components are written and the third is discarded. The coordinate representation of the data point 4 to 5 after projection onto the first two principal components is AB. Based on the above data, answer the given sub-question. And the question is, find both A and B. What is PCA? PCA is a method to reduce the number of features or dimension. But while reducing the number of features, it keeps the most important information and removes the less important direction. Every point uses two numbers instead of 3. In our questions, every point uses two numbers instead of 3. What are the principal components? W1, W2, W3 are the principal components given in our questions. Think of them as new coordinate axis. Instead of old XYZ axis, we use W1, W2 and W3. So x-axis means W1 and y-axis means W2. And now formula to compute the projection of the point onto each component is A is equal to x transpose W1 and B is equal to x transpose W2. X is our given data point, that is x is 4 to 5. Write it as a column vector. So x is a column vector 4 to 5. Now its transpose is x transpose is row vector 4 to 5. Now calculate A. A is calculated by the formula A is equal to x transpose W1. W1 is given as column vector 1 upon square root of 2 minus 1 upon square root of 2 and 0. So substitute the values. So A is x transpose W, 4 into 1 upon square root of 2 plus 2 into minus 1 upon square root of 2 plus 5 into 0. So this will give the answer as A is equal to 2 upon square root of 2, that is approximately A is equal to 1.414. Now calculate the B. B is calculated by the formula x transpose into W2. Now substitute the values of the x and W transpose in the formula. So B is equal to row vector 4, 2, 5 multiplied by column vector 1 upon square root of 2, second entry minus 1 upon square root of 2, and third entry is 0. So 4 into 1 upon square root of 2 plus 2 into minus 1 upon square root of 2 plus 5 into 0. This will give B is equal to 6 upon square root of 2. So 6 upon square root of 2 means 3 into square root of 2. Square root of 2 is approximately equal to 1.414. Therefore 3 into 1.414 is equal to 4.242. Therefore our B is 4.242. Next question, if K1 is a function of R2 cross R2 to R and K2 is a function of R2 cross R2 to R are the valid kernels, then 4K1 plus 7K2 is also a valid kernel, and options given are choose whether it is a true or false. Now understand a concept of kernel. A kernel is a function that measures the similarity between two vectors. Instead of comparing the vectors directly, a kernel compares them in a high dimensional space. The general kernel formula function is written as k of xy. Now important properties of kernel are the sum of the valid kernels is also a valid kernel. Mathematically it is written as if a kernel is valid, then k of xy is equal to k1 of xy plus k2 of xy. Another rule is a scalar multiplication. A positive constant multiplied by a valid kernel is also a valid kernel. For example, 3 into k1 is a valid kernel. Linear combination formula: if k1 and k2 are valid kernels, then k is equal to ak1 plus bk1. This is also a valid kernel provided a is greater than or equal to 0 and b is greater than or equal to 0. Now consider our question. In our question, we have given k1 is a valid kernel as well as k2 is a valid kernel. We must decide if the combination of the 4k1 plus 7k2 is a valid kernel. Compare 4k1 plus 7k2 with our general formula of ak1 plus bk2. A is 4 and b is 7. Both a and b are positive numbers and they are greater than or equal to 0. Therefore, they satisfy our rule. Therefore, 4k1 plus 7k2 is a valid kernel. Therefore, our final answer is true. Now consider the another question. If X is a data matrix of shape 5 cross 12, then X transpose X and X transpose have the same eigenvector. Answer it as a true or false. Now consider D as a 5 and N as a 12. The original matrix given has a shape 5 cross 12, meaning that it has a 5 rows, means 5 features, and 12 columns, means samples. The transpose of it means it has a shape of 12 cross 5. Now multiply x transpose and x. So x transpose shape is 12 into 5 and x shape is 5 into 12. So the final answer will be 12 into 12. Therefore our x transpose x is a 12 cross 12 matrix. Now multiply x with x transpose. X shape is 5 into 12 and x transpose is a 12 cross 5. So the x into x transpose matrix become 5 cross 5 matrix. Can x transpose x and x transpose have the same eigenvector? No, because size of the x transpose x is 12 cross 12 and size of x transpose is a 5 cross 5. Therefore x transpose x has an eigenvector with a 12 component and x transpose has an eigenvector 5 components. Since they belong to completely different vector spaces, they cannot be the same vector. Therefore our answer is false.